Okay, so there are some applications to ideas of linear transformations. One of the big ones is like using them to make transformations in geometry. So, um, we're going to work this in two space because it's the simplest place to work with. So all of these transformations are going to be from R2 to R2. And these are going to be like common geometric things. Okay, so like we have reflections, right? So we can have reflections over the y-axis, which would just be written as t of xy goes to um, negative xy. The matrix that would replace this, though, would be negative 1, 0, 0, 1. And you'll see that these are all elementary matrices. So you can literally kind of think of making transformations in geometry as being a product of elementary matrices. So this kind of harkens back to earlier in the course. If I want to make a reflection over the x-axis, this is typically viewed as take the point xy and turn that into x negative y. And the transition matrix there would be 1, 0, 0, negative 1. Okay, so if you multiply a vector by that matrix, it's going to move it over the x-axis. We also sometimes reflect over the line y equals x, right? So that transformation would be to say to take xy and make that y x. And this is basically you're switching row 1 with row 2, and that makes that transformation. Okay, so these are all the reflections. Let's talk about dilations or contractions. Okay, so if I want to make an expansion or a contraction in the horizontal direction, so a horizontal expansion or contraction. So you pick a positive number k, and we say let's take t of xy, and t of xy is going to produce x times, kx times y. That's horizontal, right? So this is just going to move us outward. The y value is going to stay the same. So the transition matrix here is k0, 0, 1. And if k is less than 1 but greater than 0, we get it contracting. If it is greater than 1, then it is going to expand. So the vertical expansion and contraction, right? So vertical expansion and contraction is housed in a linear transformation that would be x comma ky, right? So the logical matrix here is 1, 0, 0, k. And this will cause me to expand up and down from my current position. Okay, so there's also what we're going to refer to as shear. So there is the idea of a horizontal shear. Okay, and here this is the same as the transformation from txy into, and this is a little bit interesting here. So we're going to take x and then we're going to go by a multiple of y. Okay, so this is literally, in terms of elementary matrices, this is multiply the second row by k and add it to the first. And this gets me this idea of shear. So I expand above the x-axis to the right. Below the x-axis, I'm shifting to the left. So this is what we're going to refer to as the horizontal shear. A vertical shear is a similar geometric move, but it's going to be now to the right of the x-axis, to the right of the y-axis I go up, to the left of the x-axis I go to the left of the y-axis, I go down. So this would be the linear transformation txy goes to x comma y plus kx. So we're moving up and down by a factor of x. So the further I am from the y-axis, the further this thing is going to make a transformation. So this is literally take the first row, multiply it by k, and add it to the second row. So you can see how this is like building on elementary matrices from back in the day here. But this is a kind of a way to use matrices to do geometric manipulation in the plane using transformations that can be represented by matrix vector multiplication. And we'll play around with this some in class.